Hi there, I am Cypher with another video and welcome to our platform Data Science Era. And this video is about binary logistic regression. In this video, at first I will show you that how can you check the assumptions to fit a binary model, and then I will provide you a real data and show you that how can you do the analysis and interpret from the analysis. Okay, so yeah, before starting this video, I want to let you know is that if you are new in my YouTube channel, you can click the subscribe button to be notified for my next few videos. And also make sure that you download the data files I have provided you in my description box or any other area. So make sure that you download those. Alright, so let's start this video. First of all, let us know that what is binary logistic model. I just don't want to let you do all the things. If you don't have any basic idea, no problems, just follow my video. Okay, so binary logistic regression is a statistical method which predict the probability that an observation falls into one of two categories of a binary dependent variable based on one or more independent variables. What does it mean? First of all, you need to know that to fit a binary logistic model, your dependent variable should be a categorical variable. Like when I showed you how to fit a simple linear regression or multiple linear regression, on that areas your dependent variable needs to be continuous variable. Okay, but here it has to be categorical variable, the dependent. And for the independent, it can be continuous, it can be categorical. Okay, so here the idea was almost similar, but here we will actually, while interpreting or making the prediction, we use the term odds. Okay, odds, and also using odds ratio. So I expect you to have a little basic about odds. No problem, I will explain that later a little bit. So let me provide an example to understand the definition much more clearly. So here let's say your dependent variable is that getting admission at a university at USA. Okay, and you have two options, yes or no. So your respondents will give you the answer. Then if most of the respondents or a lot of respondents say yes, then you need to find out that what are the reasons that they are getting selected. What is their GPA score, what is their gender, what is their GRE score. So I have actually here three independent variables here, and two of them are continuous, GPA score and GRE score, and gender is a categorical variable. Okay, so at the end of this model you will need to interpret it in this way that if a student has a GPA score, what are the chances of his or her getting admission? Actually we'll interpret that in that way, like for increasing 1 unit of GPA, the odds of getting admission at USA will increase by that amount or decrease by that amount, or we will use the log odds in fact, and we will also interpret it by using odds by showing the percentage, that what is the percentage of the increasing amount. Okay, so that is how we will interpret that. And for the categorical variable you can compare these two. Say if you are male, then you can tell that okay, then your odds of getting admission at USA will increase by that percentage in terms of female. Okay, so that is how you will explain that for categorical variable. Now let's start this model, and before that I also let you know that what is the assumptions here. Okay, like the first assumption is that there must be a linear relationship between the continuous independent variables and logic transformation of the dependent variable. And second one is for multicollinearity, and third one is for checking outliers. But remember, these three assumptions is only for continuous independent. If all of your independent variable is categorical, you do not need to check these assumptions. Okay, that is why people want to deal with categorical variable in most cases to make it easier, because when you want to check the assumptions, if it does not fulfill, then you are in a problem to fit the model. Okay, so here one of the things which is different from the linear regression is that in terms of linear relationship, here we are using the logic transformation. Okay, at a couple of seconds I will let you know how we're gonna do that, but remember that here the linearity is a little bit different. Okay, so now let us check the first assumption fast at SPSS, then I think you will also already have idea about how to check multicollinearity, how to check the outliers. Okay, so here is the data files I have provided you, and I hope that you already downloaded these data files. Now here you can check that in the variable view we have like 4 variables. Okay, and here actually our dependent variable is diabetes. Okay, now we are asking the respondents whether you have diabetes or not. Then we want to check whether it actually depends on their age, which is continuous independent, and your gender, which is categorical male and female, and also your blood pressure, which is actually also continuous. So we have 4 variables. One is dependent, which is diabetes, and rest 3 variables are independent. Okay, now I want to check the first assumption at first. As I said, it is a little bit tricky to check this assumption in SPSS, and we are actually following the box T12 procedure. Okay, now go to the analyze, then go to the before analyzing, go to the transform and compute variable. Okay, we're actually, for the continuous variable, we're actually using the logic transformation. Okay, for that you need to use the natural logarithm transformation. Like here you have age is continuous, so you use natural logarithm ln, then give a bracket, then select it, give a double click here or just write it, and that is, and define it as a new variable. Okay, let's say the new variable is ln age. This is our new variable. We are transforming the age to ln age. Okay, now click OK. Now as we said, the the natural logarithm of age has created. Now for this another one independent variable here, we have blood pressure. So do the things similarly, like ln BP. You can write it or just make a double click. Okay, now change the variable name. Your target variable is actually the name of new variable you want to create from BP. Okay, so now we are using another transformation, and as you can see that new variables are created. Okay, now go to the analyze, then click regression. Here we are actually only checking the assumptions. To do that we have to fit the model and check the assumptions. Okay, go to the binary logistic. It's a little bit tricky, as I said already. Click reset to start again. I already did that previously. Now click diabetes independent, and then click the gender, age, BP in independent. Okay, you find it here. As you have only one variable, it's okay not to define it. Okay, if you have more than one variables, I believe you must define it, and as it has only one variable, no need. Okay, so now what you can do, click the ln BP and BP together. Okay, we're actually here using the interaction term, and click here. Previously this option wasn't activated. When you click both the things together by clicking Ctrl in your keyboard option, it is activated, and click here, then it's done. And similarly click ln age and then Ctrl at your keyboard and then click age. Okay, and similarly click here. So here we are actually calling the interaction term. Now we click OK to check the model output. Here we gonna interpret this table to check our assumptions. Let me show it in a PowerPoint slide. Okay, so here you can see in the table of variables in the equation, we are only dealing with this table. Okay, and here we are only dealing with these two values, the p value for the interaction term. Okay, now both the p value you can see is greater than 0.005. Now from the box tutorial method, this is the way to find the linearity between the continuous independent variables and logic of the dependent variable. Now if the interaction term is not statistically significant, that means if null hypothesis is accepted or the p-value is greater than 0.005, we can say that our linearity assumptions fulfilled. Alright, and later actually one correction made by some of the names, like it is known as Bonferroni correction. Actually here the p-value considered that you can consider here p-value like 0.00625 instead of 0.005. I do not want to go this method a lot, so I hope that you understand the idea how to check these assumptions. Okay, so now for the next assumptions, I hope you already know how to check multicollinearity. That means the relationship between the independent variables. Okay, you can check the VIF by fitting while fitting a linear regression. I showed you that. Here just consider any variables you like. Let's say I'm considering this variable just to check the multicollinearity, so here dependent doesn't matter. Okay, we're actually dealing with age and BP here, and click the statistics and click the collinearity diagnostics and click OK. Now here you can see that the value of VIF is very close to 1. Okay, and by using this VIF you can interpret the multicollinearity as there is no multicollinearity in this data for these two variables, age and BP. We are not here our goal is not to fit the model. I'm just trying to show you the multicollinearity. And also you can go to the graphs and check the chart builder to check whether there is outlier in the data or not. So just go to the box plot, not bar plot, simple box plot, and select the variable you want to check. Now you can select any independent variables including age and BP. If you select BP here in the x-axis, and then you'll get the box plot for one variable. Now click OK to get the output. So here you can see the output here, and from the box plot you can see that there is no outliers in the data. As you can see, there is no point outside this box plot, so we can conclude that. I hope you already watched my previous videos and you understood how to check outliers in our last assumption. Now let's show you that how can you fit the model and interpret it. Now fitting the model, actually I already showed it. Like, go to the analyze, go to the regression, go to the binary logistic, and make a reset. Now we are not interested in our interaction term at all. Okay, now click the gender in derivative in dependent, and click the gender, age and BP in independent. Okay, so here we want to check whether derivatives has any relation of these three or not. Now go to the categorical, click gender if you want to check. Okay, now if you can avoid it, I already said, so just try as you have only one variable here. Now go to the options and click classification plots and all these things that you want to interpret. Then click continue. Also go to the save option, click the probabilities if you want to check the continue, and there are a lot of options. Actually just showing you the main ideas. Okay, and then click OK to get the output. Here one important term is that reference group. I will get back to you after a couple of minutes. And now you can see here the output here. Now we are only interested in this video actually the 4-1, like the omnivorous test and model summary. At last our final interested is the variables in the equation. Okay, so the first omnivorous test. Here we actually dealing with the p-value. If the p-value is less than 0.05, then we can actually interpret that the model has a good fittings in the data. Okay, so here the null is like the model has not a good fitting, and the alternative is like the model has a good fitting. Okay, so yeah, it actually tells you whether the overall model is accepted or not. Okay, and you can also interpret it by using another test which is known as Hosmer test, and from this test actually it's a little bit different, but the idea is same. You want to interpret whether your overall model has a good fitting or not. Here the null hypothesis is that your model has a good fitting, and alternative is that your model do not have a good fitting. So here if the null is accepted, that means the p-value greater than 0.005, then we can say that okay, your null is accepted. That means the model is not statistically significant, and we can interpret it that the model has a good fitting in the data. So yeah, here you can see for both the test we can say that our model is accepted. So now we can interpret the variables, and the most important thing in a model is that you need to check whether the explained variation for the independent variable how much. Okay, we also did that like using the R-square value while fitting the linear regression model. Now from the Nagelkerk R-square is here the most accepted method, and it is a modification of the Cox R-square method. Okay, So from the model summary, if we interpret both these, then we can say that Cox and Nagelkar are square, that the explained variation in the dependent variable for this model ranges from 68.1% and 90.9%. We actually multiply this value and this value into 100. So I hope you understand that how we are interpreting the models. Okay, so now here the last one. This is the most important one, to find the predictor variable and interpret those. Now here you can see for these three variables, here the p-value is less than 0.05 for the first two and greater than 0.05 for the blood pressure. So here we have two statistically significant or two predictor variables, age and gender. So we are interested only for these two variables in this data set. And as I said already, the exponential of beta, which actually gives you the odds ratio. Okay, so now how we are interpreting this. And for the age, we can say that from this value, for 1 unit increase of age, the log odds of diabetes increases by this amount, that means 2.173. And we can also interpret this by using only odds. If you don't have idea about odds and odds ratio, actually odds is something that will tell you the likelihood of occurring something. Okay, and how we find that? We find that the probability of success divided by the probability of failure. So here the odds is like the probability of that you have this diabetes and divided by the probability that you do not have diabetes. Okay, so that is how we find the odds. And for these methods, which is in the theory, in fact, like we use the log odds, and also we can use the odds. For odds, we can say that for every 1 unit increase of age, that means if this independent variable increases by 1 unit, we can say that the odds of diabetes increases by 117.3%. is how we find this percentage, and how we actually also say this is increasing. Remember, if this value is greater than 1, then we can say this is increasing. Otherwise, if it is less than 1, we have to say that this is decreasing in terms of the independent variable. And we actually find this by subtracting from this value to 1 and multiplying it into 100. We get this percentage from this value. Okay, so that is how we actually interpret this for continuous independent variable. Now for the categorical variable, this is very important to know or to have the idea about the reference group. Remember, we have two categories here, male and female, right? Now for the female we have like 0 probably, and for the male we have 1. Now female group here is the first category, and by default SPSS always consider the first category as a reference group. Now what is a reference group? By using reference group, you're actually describing the other category. So here we are actually describing that the log odds of diabetes of male decreases by this amount compared to female. So you're actually comparing with the reference group. Okay, now if the reference group is male, then you will say that okay, the log odds of diabetes will that much increasing or decreasing compared to male. I hope you understand the idea, but let me show it for the last time in SPSS. So here in SPSS you can see that we have 0 for female, 1 for male. So the last one is male. And also for the dependent variable, here we have no for 0, 1 for yes. And at SPSS, as I said, it is always by default consider the first category as a reference group. Okay, so while we actually fitted the model by using the binary logistic option, here you can see we have gender as a category. By default we haven't defined it in categorical. Now if you want to define it here, you can select which one you want to the reference category. Now if you select the last one, it will consider the male as a reference category, and you can describe the female. Okay, and when you click continue, when you click OK, then you get the different result for this. Okay, then you have to interpret it by using this way. So I hope this video is really help you to understand the idea how to fit a binary logistic model. Make sure you practice it by watching this video and by using the data set I have provided you. And if this video is helpful for you, you can share this video to your friends or other people, and you can check our website www.datascienceera.com. We'll upload one of the best contents and for not just for SPSS, also for R programming and different languages and tools for data analysis. And yes, make sure that you check our website, and you can also join our training or consultancy program if it is helpful for you. So yeah, thank you very much.